Right now, users can view their profile, update it, and reply to threads. It's time to let them start their own discussions by creating new threads. To implement this feature, we will need a page component, a route, and some actions and mutations in our store. We can begin with the page component. Let's create a thread create page in the pages directory. As always, we will grab the markup from our mockup. Since the threads are children of forums, in order to find the create thread page, we have to navigate to a forum and hit start a thread. I will copy the form and paste it into our template. Let's see what this markup contains. The heading shows the name of the forum where our new thread will be created. In the mockup, the example forum is cooking, so here we will replace that with forum.name. Next is the form element. When the form is submitted, we want to trigger a method like create or save. We can do that by listening to the submit event. We can also prevent the browser's default behavior using the prevent event modifier. Then, we have an input for the title and a text area for the content of the new thread. So, we can bind these to a title and a text property. Lastly, we have the action buttons, a button to cancel thread creation and one to submit the form. We will figure out what we want to do on cancel once we built the rest of the functionality. Since we are listening to the form submit event, we don't have to use an event listener for the submit button. Alright, we are ready to start working on the script. Here, we likely will need to be passed a prop for the form that we will add the thread to. Next, for the data, we need a title and a text property. Lastly, we need to implement the save method. Here, we will dispatch a Vuex action, so we can create the action first. We will do that in the next lesson. In our store file, we are about to implement an action to create new threads. Like our create post action, I will name this one create thread. Let's see here. For this, we'll need the state and commit options from the context object. The payload will be the text and the title the user has written in our form. Since we don't remember what a thread object looks like, I'll go and copy one from data.json and fill it in here. ESLint doesn't like that I have the double quotes around the properties, or the double quotes around the values. I've got my IDE VS Code set up to automatically fix ESLint issues on save, so I just hit save to fix it. So the thread here contains a lot of information that we don't necessarily need at this time. We don't need the contributors. We don't need the first post ID. or the last post at and the last post ID. We also don't need the slug for now. Okay, let's see what data we actually do need. Well, we definitely do need the forum ID, and we're going to have to be able to pass that in here. So let's add that. And then we can just use the JavaScript shorthand for this property and value since the variables are named the same. We also have the title, and I'll just rearrange this a little bit. See, the text will be an actual post since the thread is a collection of posts with a title. So we'll have to add a new post into this posts array. But since we don't have it yet, we'll go ahead and remove it for now. Now, we can easily fill in the rest of the props by copying some of the code from the create post action. Now, we can use the shorthand for these properties as well. Let's go ahead and put it all on one line. Once we have constructed the thread object, we can set it to the state by committing a mutation. Following the style of the other mutations, I will create the mutation setThread that will accept the thread object, and we will just push the new thread into the threads. Now, we can commit the setThread mutation in our action and pass it the data that it needs. After we create the thread, we have to create the post with the post text. The first thing that comes to mind here is to create the post object and then commit the setPost mutation. But if we do that, then we also have to commit append post to thread in order to update our new thread's posts property. I think you get the idea. What we can do instead is to dispatch the create post action and let it do its job. Create post accepts a post object, and the post object should look like an object with a text property and a thread ID property. One bug that we can foresee is that the new thread doesn't have a posts property, so the append posts to thread mutation will throw an error. To prevent that, we can check if the thread already has the posts property, and if it doesn't, set it here. Yeah, I know that mutations should be responsible for changing only one piece of the state, but in this very situation, it's acceptable because we need to make sure that a posts array exists before adding the post ID, so we can think of it as a single state change. Now, because forums and users can have multiple threads, what we have to do is append the thread ID to their thread's property. This is very similar to what we do in the append post to thread mutation. So I will create two mutations, one to append the thread to the forum, and one to append the thread to the user. I will copy the code from the append post to thread mutation and change the variable names. I'm pressing Command D here in VS Code to select multiple instances of the variable. Now I'll quickly do the same for append thread to user. since this thread might be the first one the user has written, or this might be the first thread in the specified forum. In these mutations, we can prevent the bug of not having an array by setting forum.threads and user.threads to an empty array if it doesn't already exist. Okay, now we can commit them, and it should be good to go. Since the order doesn't matter here, we can have all the commits together. It's just better for the eye. We are ready to dispatch the create thread action in our component's save method. Here we need to pass it the forum ID, the title, and the text. We will add a route and create our first thread in the next lesson. Let's build a route to view our create thread page and see if what we've built works so far. Let's open up the router/index.js file. Here, we will import the thread create component first. I like to try to import related components close to one another, so I'll import the thread create just below thread show. Likewise, I think it's also a good idea to register routes for the same resource close to one another, so I'll search for the thread show route and add our new route below. Our new route will have the path of /thread/create. The name will be thread create, the component the same, and it will accept props. In View 2, registering this create route after the show route would have given you issues. The route would have confused the word create with a dynamic ID parameter. But because of the latest version of ViewRouter used in View 3, this is not a problem. ViewRouter is now smart enough to know that this is a direct route match, so it uses it. Okay, now we can link the Start a Thread button in the forum page to our new route. We'll change the href to a to attribute and pass it the name of the page we want to navigate to. If we go and check things out in the browser now, you'll see that we still aren't quite done yet. Clicking Start a Thread leads us to a blank page. What's going wrong? In the console, we can see what the issue is. The property name cannot be found on undefined. This is referring to our forum in the H1, so forum is not defined. We'll need to pass the forum ID as a parameter from the Start a Thread button. That way, our thread create page can get the right forum. Let's also update our route path to honor that ID. Then, in the thread create page, let's change our forum prop to forum ID. Now it'll just be a string instead of an object. And then we'll make a computed property to fetch the forum itself using the forum ID. Nice. Now it's showtime. I will navigate to the pets forum and try to create a thread. Awesome. This time it works, and we see the forum's name in the heading. Alright, now's the big time to hit publish. And nothing seems to happen. But That's okay, because the only thing the publish method does is dispatch the action. Let's navigate back to the forum to see if our thread exists. There it is. Let's open it. Besides the title and the text, I can see that the user is the authenticated one, which means that everything worked as expected. Let's also try to reply to the thread. Awesome. One quick and easy improvement we can do to our thread create page is to redirect the user to the thread he just created when he hits the publish button. So, in the save method, after we dispatch the action, we can use the router.push to redirect the user to the route with the name of thread show, and then pass it the thread ID. But what is the ID? We can't know here because the ID is generated inside of the action. This is a very common scenario to not know the ID of a resource you are about to create. To get the ID of the newly created thread, we can return a promise inside the create thread action. We could do this manually by wrapping all the code inside of the action in a promise, but I much prefer the async await syntax. Async await is a very nice syntactic sugar around promises that allows you to write code that looks more synchronous, but it's actually asynchronous. Now, we could just return the ID of the new thread, but I like to return the whole object. We can't just return the thread we have available in our thread variable because it wouldn't have attached the post yet. So we can easily find the thread in the state using the thread ID variable. Back in the save method, let's make the method async so that we can await for the create post method to be done. Then we can get the thread it returns and use it in our router.push. You may have noticed that nothing about our code at this point actually demands that our action be asynchronous. All it's doing is adding items to and getting items from the variables stored in the state. However, in general, you will have to use a promise or the syntactic sugar for a promise that is async await when you create a resource, since in order to save it in a database, you will have to make an AJAX call or something asynchronous, and we want our code to be prepared for that for later on. Okay, if we go and try it out in the browser, we immediately see the thread we create. For the cancel button, we can redirect the user back to the forum page. Let's create a method called cancel. We can use router.push here and pass in the route with the name of forum along with the forum ID. And then we'll add it to the click event of our cancel button. Let's give this a shot. Works like a charm. Once a user creates a thread, it's possible that they forget to add something, or maybe they make a mistake that they want to go back and fix. We can let users edit threads by reusing the form we've built on both a create thread page and on the page where we'll update the thread. You know what that means, don't you? That's right. Let's extract the form into a component. Let's create a file called threadeditor.view and then copy and paste the form from the thread create page into the new file. The thread editor is going to need a title and a text data property. It also needs a save method. Here we have a decision to make. One option is to emit an event and let the parent component handle it. So, if we emit an event, let's say a save event, and we pass the title and the text, in the thread create page, we will listen for this event and dispatch the create thread action. A second option is to dispatch the create and update actions directly inside the save method. Both ways are fine. I will go with the first one though, emitting an event, because we need to redirect when the thread is created, so we will have to emit an event from the thread editor anyways. We also need to emit a cancel event when the user clicks the cancel button. Great. So now let's use the component in the thread create page. First thing, we need to import it and register it. Then we can put it to use in our template. Now we should set up the event listeners. Here we want to listen to the save event and fire the save method and the cancel method for the cancel event. Now, the save method receives a payload object that contains a title and a text property. We have to update the data that we pass to the action to use what we get from the thread editor. With this refactor done, we don't need the data properties anymore. Alright, let's give it a shot in the browser. Great, everything still works. Now that the thread editor component is in place, we can move on with the thread update feature. We can use the editor inside the thread show page and switch between view and edit thread like we do with the user profile. To keep the components simple, we can create a new page component called thread edit. The idea is to pass this component the ID of the thread we are about to edit, and then make changes using the thread editor component and dispatch an action when save is hit. Since this component will be very similar to thread create, I will copy the whole component's code and paste it into our new file. In the heading, we can say editing and then the thread's title. Other than that, we don't need to change anything in the template. In the script, we don't need forum ID or the forum anymore. Instead, we need the ID and the thread we are editing. Because threads do not hold any content, we need to find the first post of the thread and grab its text property. We will use the posts property of the thread to get the post at the index of 0. This will tell us the ID of the first post. Then, we just want its text. Let's pass these to the thread editor and make it dynamic. First, we should add the props, text, and title. Now, over in the thread editor component, we should add the props, text, and title. These can be strings with a default value of an empty string. Next, we should rename the local data properties. We can go with active title and active text, or just wrap both under an object like thread or form. I'll go with wrapping the properties as it solves the collision between the prop and data names, while at the same time allowing us to reference all the form values with a single variable, that is, this.form. Now, we can assign the props values to the data properties. Since both props have a default value, this will work in any case. Also, in the save method, we have to update the payload to reference the text and the title values stored now in the form. We'll just spread the whole form into the emit event in order to accomplish this. Cool. That should do it for the thread editor. Let's go back to the thread edit page. In the save method, we get a title and a text that we will pass to the update thread action that we will soon create. Here, we will also have to pass the ID of the thread that we are updating. We have the ID in the thread ID prop. We can actually rename it to just ID since we are inside the thread edit component already. Then, once the update is done, it's nice to redirect the user to the thread page. Let's create the update thread action. Our payload here is the title and the text and the ID. In order to update the thread and the post, we can commit the set thread and set post mutations. But since we just have the title and the text, and we don't have the whole objects, we have to find the thread and the post in the state. We can easily find the thread using the ID from the payload. Once we get the thread, we can find the post using the thread's posts property and get the post with the index at 0. For the thread, we want to change the title with the new one and then pass it to the set thread mutation. Remember that we can't say thread.title equals title because we will actually update the thread immediately inside the action. So we can create a new object called newThread that will also include the old thread's properties, along with the past title. Here, using the spread operator, we are overriding thread's title. Next, we can do the same for post. Once we have these, we can commit the corresponding mutations. Whoops, I forgot to spread post here instead of thread. There is still one more thing we need to account for in the set post and set thread mutations. So far, we have only used them for setting new posts and threads, and not updating any existing ones. Written as is, they will always push a new item to post or threads in our state. Let's make it so that if the post or thread included in the payload has an ID already, we look for that in the state and update the resource accordingly. In order to know if the posts already exist in the state, we'll use find index. Then, if the ID was provided on the post, and the post does exist at a particular index in the state, that is, find index returns a -1, then we'll update the post at that index. Otherwise, we'll push the new post as we already were doing. Now, let's do the same for set thread. Finally, back up in the update thread action, let's future-proof our action by making it async. Lastly, let's return the updated thread. Now, let's create a route for editing the threads. I'll just copy the route record from thread create and change out a few things. One thing I noticed about our thread create route record is that we did misspell forum as form. We'll fix that real quick. Because we've used name routes, we don't have to worry about changing any of the links throughout the site. This route will still just work. Nice. Let's change out a few things in our new route record. For the path, we no longer need the form ID since it's already known. What we need instead is the thread ID. And it's also nice to append the word edit after the thread's ID. We'll change the name and the component used here. And then finally, we'll import the component. Great. Let's try it out in the browser. Oops, it looks like we have an issue. We forgot to update the title and the text prop on our vModels in the thread editor. Let's do that real quick. VS Code is smart enough to tell us that we can't be mutating a prop. See the squiggly red line? That should fix it right up. Alright, let's edit our thread. Great, it works. Now that we have built the thread edit feature, we can make some improvements and fix a few bugs. Let's start by adding an edit button into each thread show page. In the mockup, there is no edit button inside the thread page, so since this button will be temporary, I will add it inside of the H1. This is a link to the thread edit page. Notice that using the router link component, we can define the element we want to render using the tag option. So this will render a button instead of a link. Let's give it a shot. Nice. I also notice here the button says publish instead of update. We can fix that by displaying the word publish if the thread is new, Otherwise, we'll display the word update. To do that, we can create a computed property, something like, maybe we'll use existing, that will check if the component is passed a title. If it is, it means that we're updating an existing thread. In case you didn't know, you can convert a variable into a boolean using the double exclamation mark. That's what I'm doing here. Now, we can use our computed property in the template to show the button's label conditionally. Alright, let's give it a try. If we're editing a thread that already exists, we have update. And if we're starting a new thread, yeah, great, we have publish. The cancel button works fine when we create a thread. But it doesn't work when we edit. This is because we haven't updated the router push call. Here, we don't want to redirect the user to the forum page, but to the thread page, like we do in the save method. By now, we let users update a thread if it was them or even someone else who has created it. Later on, we will limit the user's abilities so only moderators can edit all threads, while normal users are able to change only the threads that they create. In this lesson, I want to spend just a few minutes drying up our code a bit and extracting some lengthier code I see repeated throughout our store file. Dry, D-R-Y, stands for Don't Repeat Yourself. It's a philosophy for code that not only is easier to read, but also easier to maintain and extend as it makes common functionality or configuration variables readily available. You'll see what I mean in this lesson. It's common practice in most any language or framework to have a helpers directory where we can store any general and reusable functions. Since we won't have many right now, we'll just add a single index.js file. The first method I want to create is going to be called findById. If you look throughout the store file, you'll see that it is very common to look through a particular array of resources to find a single one of those resources by an ID. For instance, here we are looking through the users to find the user with a particular ID, that is, the ID of the signed in user. Here, we are looking through the threads to find a thread with the ID that matches our ID parameter. Here, we are looking through the forums to find the forum that matches a certain ID. In all these instances and more, you can see the same pattern. Call .find on the resources array and provide a callback function that compares the ID property on each resource to some given ID. So, let's extract our helper function now. In the new helper file, let's create and export a function. The function will need to take a resources param and an ID param. The resources param is an array of resources that we want to look through, i.e., posts, forums, threads, users, etc. The ID is the ID of the resource that we want to find. Let's just paste in the code from one of the instances in the store and change out the variables. State.forums becomes resources. Forum can just be R, or in other words, the current resource being iterated over. And finally, forum ID becomes ID, that is, referring to the ID param of the function. Cool. Now let's go put our helper function to good use in the store. First, we need to import our helper function. I'll look for all the instances of .find in this file in order to help us move a little bit more quickly. I mentioned earlier that helper functions are meant to be more general use and reusable throughout the codebase, and the find by ID function is actually a perfect example of that. We can search for .find throughout the codebase and use the new find by ID for many of those instances as well. I won't make you watch me replace every instance, but essentially I'll do exactly what I did in the store file, and you can see exactly what changed in the source code link below. I've gone through all of the other code and replaced instances of .find with find by ID where I could. And then I've checked everything in the browser just to make sure everything still works. And yeah, I think everything looks good. There is one more piece of functionality in the store that I think merits being extracted into a helper function. Take a look at the code for the set thread and the set post actions. They are essentially identical, just with the instances of thread switched out for post and vice versa. The point of the code in each action is meant to update the resource if it exists, and if it doesn't exist, add it to the array of resources. In code speak, this is often called an upsert. Think of it as the words update and insert smushed together. While we'd only be cleaning up two functions by extracting this code into a helper function, I still think it's a good candidate for extraction for a couple of different reasons. One, it's complex enough to not want to have to write it more than once. Two, if you think about it, upserting could become a very common thing, done not just for threads and posts, but also for users and forums, and then who knows what else as our app grows. So let's do it. In the helper file, let's create and export the upsert method. It will take two parameters, the array of resources that act as the source of truth for existing resources, and the new resource to be added. Alright, now let's copy the meat of the setPost action and paste it in. Let's change out these variables to come from our parameters on the function. Oh, and it looks like I misspelled upsert as well. Finally, let's use the upsert method inside of our actions. Let's import it and then use it. We don't need all this stuff anymore. Alright, one more time, let's make sure we didn't break anything. Great, we've dried up our code and everything is still functioning. In this lesson, we will take a look at one of the cool benefits of functional programming. Specifically, we will play with higher order functions. We all know how to create functions like this one, that doubles the number that you give it. But, did you know that you can assign a function to a variable and then use it? Now, higher order function is just fancy terminology for a function that either accepts a function or returns a function. There are many higher order functions that we use daily, like array map, reduce, filter, and so on. Array filter, for example, accepts a function that handles the logic on which items to include in an array. Here, I have an array of characters where each character has a name and an attribute specifying if he is a bad guy or not. In order to create an array with only the bad guys in it, we'd use filter and keep the ones whose bad guy property is true. So here, we pass a function called callback function that checks if the character is a bad guy or not. We could also assign the callback function to a variable and use it like this. Here, the filter method creates a new array with the characters that pass the isBadGuy test. The benefits of using higher order functions are that the code is reusable and you write less. And when you write less code, the quality is usually higher, and it's easier to prevent bugs. Though the array filter doesn't make these advantages clear. So, let's see how we can benefit from using higher order functions in our applications. Here is a function, fetchResource, that receives two arguments, the name of the resource and the ID. And then it returns an AJAX call. So, in order to fetch a user, for example, we can call the fetchResource function and give it the resource, which is users, and the ID of the user that we want. Instead of using that every time we need to fetch a user, we might want to create a fetchUser function that will accept the ID of the user to fetch. Then we can reuse fetchResource by passing it the name of the resource, which is users, and the ID argument. Now, if we run fetch user 3, it will fetch the user with the ID of 3. That's good, but what if we wanted to have functions like fetch theater, fetch movie, fetch ticket, and so on? We would have to create each one separately. Using higher order functions, we can create a function that produces other functions. This way, we will be able to create the fetch theater function by writing something like this. To show you, I will create the makeFetcher function that will accept one argument. This argument will be the name of the resource that will be included in the URL. For the fetchTheater function, for example, the resource would be theaters. MakeFetcher has to return a function. This function will also accept a parameter, and this parameter will be the ID of the resource that we want to fetch. For the fetch user example we ran before, the ID argument was the number 666. In the returned function, we want to call fetchResource and pass it the resource and the ID. Now we can create a fetcher function like fetchTheater. Notice how the returned value is a function. Now, running fetchTheater3 performs an AJAX call to the /API/theaters/3 and returns a promise. This way, if we make changes to the fetchResource function, because, for example, the URL from the API changes, we don't have to update the rest of the functions. Some might want to perform the AJAX call directly inside of the makeFetcher function, but I prefer to extract it for testability. It also makes more sense to me to go and update fetchResource instead of makeFetcher when, for instance, the API routes change. I hope you're excited about using higher order functions in your projects by now. They're great for composition and reusability. Before we move forward, I'd like to show you how all these look using arrow functions. The fetchResource function will look like this. It accepts the resource and the ID as parameters, and then it uses the resource in the file path that is being called, and the ID in the file path as well. Then, makeFetcher accepts the resource, and it returns the function that accepts an ID and returns the result of calling fetchResource, passing the needed arguments. There is no difference on how we use the functions to create fetchers, so fetch users will remain the same. Personally, I don't use a ton of higher order functions that return a function, but knowing how to do it and when to do it can really add to your coding arsenal. In our store, we have many mutations that do the same thing. I am referring to the append X to Z mutations. Each one of these mutations accepts a parent ID and a child ID. Here, the parent ID is the thread ID and the child ID is the post ID. Then, it finds the parent resource in the state, in this case, the thread. It checks if it has a property to append the child ID to, and then creates it if it doesn't. Lastly, it pushes the child ID to the property of the parent. The difference between all these mutations is the type of the parent and the property name to append the children to. So, we can create a higher order function that will create these mutations for us. I will create a function right before creating the Vuex store. I will name it MakeAppendChild2ParentMutation. This name is quite long, but it's fine since it is descriptive and will only be used internally to create mutations. To get started, I will copy the code from one of our mutations. Right now, this function returns the append_post_to_thread mutation. So if we call it where we define the mutations, we shouldn't notice any changes, right? Let's create a post to find out. Everything works fine. How I'd like this to work is I'd like to give the MakeAppendChild2ParentMutation function the parent and the child, like threads and posts, and get a mutation that appends a post to a thread. Back in our function, I'll add these arguments. Remember that this function returns a function that is the mutation. What we want this mutation to do is to find a resource first, like a thread, and then append the child ID to a specified property. So that we can start thinking of this function as dynamic, I will rename the thread variable to resource. When we called this function, we passed the threads value as the parent and the posts as the child. So, we can rename the thread ID to the parent ID and the post ID to the child ID. With the code we have right now, the resource will always be a thread. So, we can replace that with the parent argument. Because we cannot use a variable after the period, we can write it like this. In case you didn't know, typing user.name is the same as typing user bracket name bracket. Let's do the same for the child and replace resource.posts with resource child. So now what we have is a function that returns a function. The function returned accepts the state as the first argument, as our mutation did, and the second argument is an object with a parent ID and a child ID property. And since we bind this function to the append post to thread mutation, now the mutation needs the parent ID and the child ID instead of the thread ID and the post ID it used to accept. So let's update the code where we commit this mutation. Let's give it a shot in the browser by creating a post. And it works fine. So now we can use our awesome MakeAppendChild2Parent mutation function to generate the rest of our mutations. I love how short they became. Now, we just have to update the places where we commit a pinned thread to forum and a pinned thread to user mutations with the parent ID and the child ID properties like we did for a pinned post to thread. Alright, we're ready to check it out. I will create a thread. I will make a post. Cool, everything is working good. If you are wondering about where we should put the makeAppend function, we could put it in the helper file or create something new, but since we're only using it in the store, it's fine to leave it in the store file. I would like to move it to the bottom though. I want to do this because it's more of an implementation detail. In other words, moving through our store file from top to bottom, I really want to see state, getters, actions, and mutations of our store first. And then any supporting code like this function is last priority, and you really only want to look at it if you want to know how the append child to parent mutation works in detail. In order to do this, we will have to make one slight change to the function definition. Instead of creating a variable and assigning it a function, we will use the more traditional function declaration syntax. This is necessary because the function is defined after it is called in the mutation above. Variables declared with let and const must be declared before they are used, and this is a good thing that helps to keep your code more error-free. Functions defined in this traditional syntax, however, don't have to be. This is because of a JavaScript concept called hoisting. The function behaves as if it were hoisted to the top of the file and defined before it was called. This exact situation of defining functions that act more like implementation details at the bottom of a file is really the only good thing I know of about hoisting, but it definitely helps with code organization and readability. In the mockup on the thread page, there is some text after the H1 that indicates who started the thread and when. There is also this bit of text that shows a count of the replies and the number of contributors. Let's use what I like to call a dynamic getter to get this working. First, let's copy the markup from the mockup and paste it into our thread show page under the H1. The first thing we need in order to fill this in is the name of the user. But if we go back to the browser and inspect with View DevTools, you'll see that we only have the user ID on the thread. So, we need to get the user whose ID matches this user ID. It looks like we'll also need some sort of replies count and contributors count. We could create a computed property to handle these different pieces of info that we need from the thread. But because they could be useful in other parts of our application, let's go ahead and do this at the store level. In our getters property of the store, I'm going to create a new getter called thread. I want this getter to be able to return an object describing a particular thread. Only with some extra properties like author, replies count, and contributors count. The first problem we run into here is how do we tell the getter which particular thread we want the data for? Getters don't normally accept parameters. This is where we can make use of a higher order function to create a dynamic getter. We'll return a function from our getter that takes the thread ID as an argument. Then, we'll use the findById function to get the thread that we're looking for. Even though we haven't gotten any of the extra data yet, let's go ahead and try out our dynamic getter in the thread show page, just to make sure everything is still working. We can replace our computed property for thread with the getter. We can also remove the import of the findById helper function, as we're no longer using it. If we take a look in the browser, we see everything is still good. Nice. Now let's add that extra data we need. These so-called extra properties can be computed using properties already available to us on the thread. We don't always need these properties on the returned thread, so let's create the properties using native JavaScript getters. This way, the computation only happens when we access the property. We can use findById on the users to find the author of the thread and their name. Next, we can compute the replies count using the post property on the thread. The post property is an array of post IDs associated with the thread. Because the first post is not really a reply, but instead the content of the thread itself, let's subtract 1. Contributors count is going to be just a little bit more difficult. If you look at our data, you'll see that we have a property in thread already to store the contributor's ID. That means we should be able to do similar to what we did on the replies count. Unfortunately, we haven't actually been updating our contributors property yet. However, we did just make a super sweet higher order function in the last lesson to easily make append child to parent mutations. Let's use it to make an append contributor to thread mutation. And then let's commit the mutation whenever we create a new post. There's still one more thing we have to account for here. All the other times we've appended a child to parent with a mutation, it's always been unique, just by the nature of when and on what IDs we call the mutation. If we do not change something, our contributors count property will continue increasing with every reply to the thread, even if that reply was from a user who already replied. The reason for this is because we're calling the append contributor to thread mutation on every post creation, and users can reply to a thread multiple times. So, let's make a quick change to the make append child to parent mutation function. We'll add the child ID to the parent resource only if it doesn't already exist. The JavaScript array method includes will tell us if the ID already exists in the array. That should do it. Now we can use our thread's extra data provided by the native JavaScript getters in the template to fill in the missing data. We should also use our handy appDate component to transform the thread published at property to a user-friendly display. Over in the browser, that text under the header should be correct now. And it looks like it is. We have the author correct, and we have 3 replies by 3 contributors. 1, 2, 3 replies, not counting the original one, and then 3 contributors: Joey, Theodore, and Ray Nathan. And if we add a new reply as the Batman user who hasn't contributed to this thread yet, replies and contributors both correctly go up to 4. Don't mind the missing image here, it's just an internet connectivity issue. If we hit reply once more, you'll see the replies go up by 1 again, to 5 this time, but contributors does not. It stays the same. Perfect. We've made some great progress with our forum, and we're really close to being able to set up a database and make our data persistent. I'm very excited about that. But before we start working with Firebase, let's fix a couple of small things. In the last lesson, I noticed an issue on the Vehicles forum page listing out all the threads. You'll see the replies column is off by 1. That's because we were counting the initial post as being a reply. Let's change that in threadlist.view to use the thread.replies count that's now available via the thread getter. Thread is provided as a property to the threadlist component. Let's make sure it's the thread from the getter that actually has a replies count property. The threadlist component is used in forum.view. We see the threadlist component is passed a variable called threads. which references a computed property. Let's alter the forum page's computed prop to get each thread using the dynamic getter. Instead of filtering through all the threads, we can now use .map on the forum's thread property, which is an array of thread IDs. And for each thread ID in forum.threads, we'll call the getter. Cool, that's looking good. Let's add one more post for good measure. Yep, now those thread counts are consistent. Great. Another issue I see on the thread page is that all the users are said to have 107 posts. This is not accurate. Let's fix that. This page is powered by the thread show.view component and uses the post list component to display the associated posts. In a previous lesson, we used a Vuex getter to retrieve the auth user along with the auth user's post count. Let's refactor just a little bit to make a getter that applies to any user so that we can use the native JS getter posts count on the thread page as well. We'll create a new dynamic getter called user. It will look a lot like the thread getter from the last lesson, returning a higher order function with an ID argument. Now, we'll cut the code from inside the auth user getter and paste it into the new user getter. We'll need to change out state.authID here for the ID passed into the anonymous function. This, of course, has broken the auth user getter, but reviving the auth user getter is now as simple as calling the new user getter on the auth ID. We can access other getters from inside a getter by adding a second argument to the function we use to define the getter. Wow! Refactors are really simple when your code structure is well thought out and executed the first time around. That should do it for the Vuex store side of things. Now let's use the user getter over in postlist.view to display the proper post count. We can replace the call to find by ID in the user by ID method with the user getter. Find by ID can also be removed as it's no longer in use. In the template area, we now have access to the posts count on the user getter. In the mockup, I also see that each postcard has the user's total thread count as well. Let's not upset our designer by forgetting to include that. Luckily, the user getter has a threads count getter on it as well. Easy enough. It's time to integrate a database and store our forum's data. Throughout the master class, we will use Firebase to cover our back-end needs. Firebase is a Google Cloud solution that covers an array of needs such as hosting, authentication, server functions, file storage, databases, and more. We'll be using the Firestore database to persist our forum data. Firestore is a NoSQL document database that lets you easily store, sync, and query data for mobile or web apps. We will also be using Firebase Authentication, which makes it really easy for users to register and log in, while it also supports multiple providers out of the box, like Gmail, GitHub, Twitter, and Facebook. Later on, we will create cloud functions to calculate forum statistics and other cool stuff. When users are able to set their avatars, we will take advantage of cloud storage that is easy to use and fairly cheap. Lastly, we will see how we can make our forum public to the world by deploying it to the Firebase hosting. If that sounds like a lot, don't worry. Right now, we're going to be focusing on the Firestore database and persisting our forum data. If you've never used Firebase or Firestore before, no worries. We're going to take things slow, and I'll show you everything you need to know to get it working with our forum. If it would make you a little more comfortable knowing more about the Firestore before jumping in with me and using it in our forum, feel free to check out the Quick Start Guide in the official Firestore docs provided in the description below. Okay, I'm excited to get started with Firebase. Let's visit https://console.firebase.google.com to open up the Firebase console. Alternatively, you can find a link to the console in the description below. Alright, now click Create Project. I'll call it View School Forum. Accept the Firebase terms, and then click Continue. We don't need any analytics, so let's just toggle that off for now. And click Create Project. It might take just a few moments for the project to be created. After the project is finished being created, click Continue. Nice! Now we've got a dedicated project for our forum app set up in Firebase. It's telling us we can get started by adding Firebase to your app. Let's do that. We'll choose Web. Let's name the application View School Forum, just like the project. And we'll leave Firebase hosting unchecked at this time. Click Register App. Now we're presented with some code that we can add to our project in order to install Firebase. The option presented here for installation is linking to the JavaScript dependencies via a CDN URL in a script tag. That would work fine, but I prefer handling JavaScript dependencies with npm, so let's install Firebase via the terminal. I'll use the built-in terminal that comes with VS Code. Here you need to type npm install --save Firebase. Once it's installed, we have to connect our application with the Firebase project using the code snippet we see in the docs. We need to place this snippet somewhere that will always run and only run once. This sounds a lot like our main.js file that bootstraps our application. So, here in main.js, we import the Firebase module and then we'll initialize it. Make sure to provide your own values for each of the properties in the config object. Also, I'm fond of storing configuration data like this in dedicated config files. It's great for organization, and you never know when you might need access to the configuration variables elsewhere. Let's do that real quick we'll create a new folder called config, and inside of it, we'll create a new file called firebase.js. Inside of firebase.js, let's paste our configuration object. We'll export this config using the CommonJS module export syntax. This will be just in case we end up having to run some sort of Node script that needs access to these variables without running it through Webpack. Finally, let's import the configuration into main.js and use it. If we check the browser, we don't see any differences, but we also don't get any errors in the console, which is a good thing. In the next lesson, we will set up the Firestore database and connect it to our application. The Firebase Cloud Firestore is a cloud-hosted database. It's known as a NoSQL database because it stores data as JSON, unlike traditional SQL databases. If you're new to Firestore, don't worry. I'll walk you through everything you need to know to use it in the forum. If you'd like more info, check out the official Quick Start Guide linked in the description below. Let's set up a Firestore database in our Firestore console. From the project overview page of the console, we can see this card for the Cloud Firestore. Let's choose that to get the Firestore database up and going. Now you can click Create Database and choose Start in Test Mode, as that will give us the most flexibility for now. Next, we're prompted to choose a location for our database to live. This is the literal geographic location of the servers that our database will live on. If you know a thing or two about the audience for your site, it's best to choose a location nearest your site visitors. The closer the server is in geographic space to a site visitor, the faster the server can respond. If you don't know this information yet about your audience, no worries. You can just choose the location nearest you, and then click Enable. Give it just a few seconds to set things up. And just like that, our database is good to go. The next step is to get our data into the Firestore database. So, how do we import the data? Well, I've provided a little Node import script in the links below that we can run. The script takes advantage of an NPM package called Firestore Export Import that does much of the heavy lifting for us. It also does just a little reformatting of the data so that it gets into the Firestore with IDs intact. Our data stores all resources as an array like this. In order to make the IDs the actual document IDs in Firestore, and not just another document property, the Firestore Export Import package needs our resources instead to be an object. With the key being the record ID. Therefore, in the transform data for Firestore function, we loop over each collection of resources, transform it from an array into an object in a newly created variable called collectionsById, and then assign the record to the object with the key being the record ID. Go ahead and visit the link below and copy the code to your clipboard. Then, in the root level of the project, create a new file called firestoreimport.js. After you've copied and pasted that, let's install the Firestore Export Import Node module from NPM. Next, over in the Firebase console, we need to generate a key for the Firebase service account. Navigate to the left sidebar and click on the Settings icon. Choose Users and Permissions. Navigate to the Service Accounts tab. Choose Node.js, which should be the default option. Click Generate New Private Key. In the pop-up, click Generate Key. A JSON file should have downloaded to your computer. Open it up and rename it to serviceaccount.json and move it to the root of the project. If you're version controlling your project in Git, make sure to add serviceaccount.json to the .gitignore file. This is important as you don't want the sensitive information in this file to get into your repo. If you aren't using Git, don't worry about it. Now, all that's left to do is to run the import script. Run the following command in your terminal: node./firestore-import.js. This might take just a second, so feel free to pause the video and come back when it's completed for you. Now, if we take a look at the database in the Firebase console, we should see our data. Great, there it is. According to the documentation, each Vue instance goes through a series of initialization steps when it's created. For example, it needs to set up data observation, compile the template, mount the instance to the DOM, and update the DOM when data changes. Along the way, it also runs functions called lifecycle hooks, giving us the opportunity to add our own code at any specific stage. A Vue instance is created when we use the Vue create app function, as we do in main.js. Also, each component is a Vue instance. Let's take a look at the lifecycle hooks. The first hook to be triggered is the beforeCreate hook. Then, Vue initializes the instance's reactivity and calls the created hook. Then, it makes some checks to decide if and how to mount the instance in the DOM. When this phase is done, it calls the beforeMount hook and the mounted hook accordingly when the template is rendered. Here, on the right, we see the beforeUpdate and updated hooks that run when data changes. Later on, when the component is about to be destroyed or unmounted, the beforeUnmount and unmount hooks are triggered. Alright, enough theory. Let's see how we can use the hooks in our application. I will go to the home component and log a message in the console right before creating the component, thus inside the beforeCreate hook. If we take a look in the browser, we see the message in the console. You should know that the beforeCreate hook triggers before the instance is created. Thus, the reactivity is not set up yet. This means that we cannot access or update any data. So, if I try to log the category's computed property along with the message, it will be undefined. The next hook is the created hook. This hook triggers when the instance is created, but before its template is rendered in the DOM. Here, we have access to the component's data and computed properties. This time, since the category's property is available, we will see its value in the console. The created hook is a great time to fire an AJAX call, so that it has just a little more time to load before the component is visible to the user. Next up, the before mount hook is triggered. This happens when the component's template has been compiled and the virtual DOM has been updated. Once the virtual DOM is updated, Vue moves on and updates the real DOM. Think of the real DOM as the document that users see in the browser. On the other hand, the virtual DOM is a local and simplified copy of the real DOM. The virtual DOM is a mechanism used by many frameworks like Vue.js to do computations and decide what and when to update the actual DOM, faster than updating it directly. The mounted hook is similar to jQuery's ready function. Here we also have access to the special $L property. The $L property contains the DOM element. We can use it to access the element's attributes, such as the inner text, for example. These are all hooks related to creating and mounting our instances. Mounted and created are the ones I find myself using the most. There are also two hooks fired when an instance is being unmounted. An instance is unmounted when it's removed from the DOM. When you render a component using vIf, for example, when the condition is not met, the component is being unmounted. So, before unmounting the instance, Vue triggers the before unmount hook. In before unmount, the component is fully functional. Whenever you need to turn off event listeners, this is the best place to do it. After that, the component is unmounted and the unmounted hook triggers. Thus, in here, we do not have access to the $L property. Here, you can do stuff like informing a third party that the component is destroyed, but in most cases, this hook is not needed. Inside the browser console, we can now see all the hooks firing one after the other. In order to unmount the component and see the before unmount and destroyed hooks being fired, we can navigate to another page. We are using Vue Router, and of course it's smart enough to unmount a page component when we navigate away. As we saw in the lifecycle diagram, there are a couple more hooks that trigger when a Vue instance is activated or when data updates. Their use is more rare, but if you need to use them, you can find more information in the API section of the Vue.js website. With the Firebase project set up and the lifecycle hooks fresh in memory, we are ready to start migrating our application to use the data from the database instead of the JSON file. As of now, all of our data comes from the data.json file and is static data. That data gets loaded into the store via a simple JavaScript module import and is accessible in the components via this.$store.state. This keeps things simple for development in the beginning, but it is not a permanent solution. Let's remove that static data now and work on reading the data from the Cloud Firestore into the Vuex store. The first thing I will do is to remove the source data from the store. This will of course start flooding our app with errors, as the app's data is an important piece of the puzzle. Let's take a look at the console and start resolving some of the resulting issues one by one. The first error we're faced with is cannot read property find of undefined. This is because we're trying to get the auth user for displaying in the nav bar, but the user's property does not exist in the state. Let's update the findById method to return null if the resource parameter is falsy. Cool, that takes care of the first error. Now we get cannot read property avatar of null. This is because our auth user is now null, and we're trying to get the avatar property on it for display in the nav bar. Let's just conditionally show the li with the class of navBarUser only if the auth user is defined. Great, it looks like our home page is now error-free. This is a good start. Another thing to do is to initiate the necessary state properties. When we fetch the data from the Firestore, we will use our mutations to update the state. This means that the state needs to have the properties already existing, like posts, users, etc., in order to append the new data to. So, let's add a state property for each of the resources we have. Each of these properties must be an array, and since we don't have any initial data, we can set them to empty arrays. There's still one last cleanup item we need to do in the store here. The setUser mutation isn't using the upsert method and will only set a user's data if that user already exists. That will be an issue when we try to commit the setUser mutation to set a user from the Firestore into the empty user state. Let's make it match the setPost and setThread mutations. Now, let's start working on fetching the data from the Firestore. The data we need to fetch will depend on the page the user is browsing. When we browse to the home page, for example, we need all the categories and their forums. When we browse to the thread page, we need the thread, with the specified ID in the URL, its posts, and the users who created them. This might sound chaotic in the beginning, but the good news is that each page component acts like a map, guiding our decision on what data to fetch. Let's get started with the thread page. The first data we need is the thread. Once we get that, we can figure out the next needed resource. I will import the Firebase library in order to be able to use it. It's important to note that when we fetch data from an API, the code runs asynchronously. So the earlier we instantiate the call, the more time it has to resolve before the user sees the page. With that in mind, I'd like to fetch the data in the beforeCreate hook. But if I do that, we won't be able to access the props, since the component's reactivity is ready in the created hook and after. Thus, here, this.id will be undefined, and we won't know which thread to fetch. So we will use the created hook instead. Now, I'll call the firebase.firestore method to query the Firestore. We're looking for a record, or a document, in the threads collection where the document ID is equal to this ID. you can listen to a document with the onSnapshot method. An initial call using the callback you provide creates the document snapshot immediately with the current contents of a single document. Then, each time the contents change, another call updates the document snapshot. So, we want to call onSnapshot, and in the callback function, commit our setThread mutation. The callback function provides a doc parameter where we can access the response from the Firestore. To get the data associated with the document, aka the thread, we call .data. The data method does not include the document ID, however, so we'll spread doc.data into an empty object and then set ID to doc.id. The setThread mutation takes an object with the thread property set to the thread we want to set. We can use the object shorthand property to set it. Now, if we look in the browser, we should see some of the basic information about our thread. Whoops, we're getting an error. This is referring to this name property here of author. We have not fetched the user for this thread yet, and so author is undefined. In case you did not know it, you can use a question mark before a property name to make it optional. Great, now we have that basic information. Once we have the thread, we can fetch the user who created it. To do that, we can copy and paste what we did for the thread and change what's necessary. Notice we have to call this inside the callback method from getting the thread. This is needed because we must have access to the thread.userid property. Next, we need to get all the posts associated with the thread. To do that, we can loop over each post ID in the thread.posts property. Then, we can copy and paste our call to the Firestore again and change out variables as necessary. We also need to get the users for each of the posts here as well. And actually, we need to get the user after we have the post available. That is, inside the callback function for fetching the post. Now, we only have the thread title and the initial post. The reason for this is because we're setting our posts to the store before we have the users associated with them. Therefore, for a split second, the post list component can't read the name of the user. We could nest the setPost mutation inside the callback to get the post user. However, I think what I'm going to do instead is just make a conditional in the post list component to only show the user if it exists. Awesome. The code we have right now is far from perfect. It's hard to read. It's not being cleaned up properly in an unmounted hook. And it's very repetitive. We'll work on these things in the next few lessons, starting with moving our code from the created hook to some Vuex actions. The way we fetch the data from Firebase in the created hook is fine for prototyping, But now that we got it working, we should tidy it up. In Vuex, actions are responsible for dealing with asynchronous code, like the Firestore calls, and we should not commit mutations outside of actions. So, each Firestore call should be an action. Let's start with the fetchThread action. This action needs to know the ID of the thread to fetch. Let's log a message in the console here to indicate that we are fetching a thread from Firebase. In here, I will move the code that gets the thread from Firebase. The squiggly red line here under Firebase is letting me know that it's not defined. That's because we haven't imported it into the store file yet. Let's do that. Then I'll switch this.id with the ID argument and remove this.$store. When we call the fetchThread action, we need to know when it's done, so we can proceed with fetching other related resources, such as the thread's user. Thus, we can return a promise that will resolve when the Firebase call is done. That is, inside the callback after committing the setThread mutation. In Resolve, we can pass the thread object. Let's use our action in the thread show page. We can remove the manual call to Firestore for the thread and replace it with a call to dispatch the new fetchThread action. Since the action returns a promise, we can change our created lifecycle hook to an async function, and then get the value of the thread by awaiting the return of the dispatched action. Let me also clean up a couple remaining characters from when we were manually calling the Firestore. If we take a look in the browser, everything works as before, and this time we also see the fire message in the console. We can move on now with the rest of the resources. Here we fetch the user, so let's create an action for that. I'll duplicate fetchThread and make the necessary changes. Back in the thread page, we can replace that with our action. Here, we don't need to do anything when the action is done, so await is not necessary. We also fetch the user for each post, so we can use our action there as well. Okay, lastly, let's create an action to fetch a post by duplicating fetchUser and making the necessary changes. And now we can remove the manual call to Firestore for the posts in the created hook and replace it with our action. We will need to make the callback function for the forEach async so that we can then await for the result of the post. With that, we've managed to make our component's code shorter and create reusable actions while we are following best practices and we don't commit mutations directly from our components. We are not using the Firebase library in thread show anymore, so let's just remove that import statement. If we check it out in the browser, the thread page works just fine. And we also get to know what's going on by reading the console messages. In the previous lesson, we created actions to fetch threads, users, and posts from our database. I'm sure you noticed that all these actions do the exact same thing, with their only difference being the resource that is fetched. One approach to eliminate this code repetition is to compose these actions using higher order functions, just like we did for the append x to y mutations. If we take that path, it will be easier for us to make changes in the future. If, for example, we need to manipulate the incoming resources, in addition to assigning the ID to the doc.id. Though there is a simpler approach, which is to create a generic action, like fetch item, and reuse it to create one of our fetch actions. To get started, I will copy the fetch post action, and I will create fetch item from it. Let's see which static values we can extract to arguments in order to be able to create fetch actions for any given resource. In the first line, we log a message with the chat emoji for posts. Because each fetch action displays its own emoji, the emoji can be one of the arguments. Next up is the collection name to get the resource from. Let's call this argument resource. The next thing our actions do is to store the value of the snapshot into a variable and call a setX mutation, such as setPost. One approach to make this dynamic is to extract the name of the mutation into an argument, that is, the setPost mutation. Though, because all the setX mutations follow the exact same pattern, and because it's a burden to create a new one for each resource, like the categories and the forms, we can create a generic mutation like setItem. That will accept the name of the resource so that we can locate and set the item in the state. Looks good. Let's go back to our action where we can use our new mutation setItem. We'll pass it the resource argument along with the ID and the item object. Here, I will also rename the post variable to item to make it more generic. And that means we can use the object property shorthand here. It's also handy that setting the